If you're like me and you took math in the United States, you probably learned in 7th or 8th grade that if you knew the slope of a line and one of the points on the line, you could plug that information into either this formula or this formula. They're the same in this formula, we just take that y1, add it to both sides and move it over here. That you could find the equation of a line, and that this form of the equation of the line was called point-slope form. And also, if you are like me, you might have found this a little bit mysterious. I understood in 8th grade that you could use a point and a slope to draw an entire line, so I knew we had enough information to write the equation of the line. I just didn't understand where this equation came from. y1 and x1 are the coordinates of the point here, and I didn't understand why you would subtract the x-coordinate and add the y-coordinate, or in this case, subtract the y-coordinate over here and subtract the x-coordinate over here. I didn't understand why the slope went out here in front of the parentheses. I just didn't really understand where this equation came from at all. So I'm hoping in this video I can give you a more intuitive visual explanation of why point-slope form works. Now, what we're really talking about when we're talking about different ways to write the equation of a line is we're talking about different sets of instructions for how to make the line on a graph. When I write a line in slope-intercept form, these are the instructions I'm giving. First, make a line, then make it as steep or as unsteep as you want, and then move that whole line up or down to intersect with the y-axis at the right place. But there are lots of other instructions we can give that move the line around in different ways. For example, if I add 3 to the x-coordinate, then I move the line 3 to the left. If I subtract 3, the line moves 3 to the right. A lot of people find it unintuitive that by adding 3, we're moving the line to the left. They think it should be the other way around. One way to think about it is that the y value I get when I plug in 3 normally, which is going to be 10, when I add 3, that's now going to be the y value I get when I plug in 0. So it moves the whole line to the left. As well as moving the line to the left and the right, I can also, of course, fiddle with the slope to make things steeper or less steep. And I can add or subtract any number from the y value to move the line up or down, just like we saw before. Now let me go back to my original line, and I'm going to try to see if I can make the same line in a different way. So I'm going to start by making another line with the same slope that goes through the origin. And I'm going to recognize that because these two lines have the same slope, if I push this blue line up to intersect with any point on this red line, the lines are just going to overlap each other and become the same line. Instead of pushing it up to the point 0, 4, I'm going to try to drag it over to another point, like 2, 8. So I'm going to move it up 8, and I'm going to drag it over 2. And that's another way to make that line. I could do this again. I could take a line that goes through the origin with the same slope, and I could drag it up to, let's see, 412. I could also try to drag it down to a point down here if I wanted to. There are infinite ways for me to construct this line. You might have already realized is that in the process of taking lines and dragging them up to a point on our y equals 2x plus 4 line, what we're doing is we're writing equations in point-slope form. Here's our slope, here's our point, 2, 8, here's our other point, 4, 12. Just like we're supposed to do in point-slope form, we subtract the x-coordinate of the point, and we add the y-coordinate. To get either of these equations into the more traditional y minus y1 equals slope times x minus x1 form, all we need to do is subtract the y value from both sides, so this becomes 0, and that becomes y minus 12. So essentially, point-slope form works because there's more than one way to construct a line. We can start with the slope and then bump it up or down to an intercept and then get something in slope-intercept form, or we can start with the slope and drag the line over to a specific point. And that's how we get point-slope form. Point-slope form and slope-intercept form are just two different sets of instructions for how to make the same thing. I hope I could make point-slope form a little bit less mysterious, and if you know another sort of intuitive way of explaining why point-slope form works, please let me know in the comments. Sorry my voice is a little hoarse today. I'm having some trouble with spring allergies.